Okay, in last session we discussed about UVM sequence and body method which is present inside UVM sequence. Inside the body method, how we are generating the sequence, okay, what are the methods available. So we discussed UVM macros which is used for generating the sequence. Okay. So today's session we are going to see the handshaking mechanism happens between the sequencer and driver. Okay. How the sequence item is transferred to the driver. Okay. That process we are going to see in this session. So this is the connection between the sequencer and driver. Okay. This one you know, right? In agent part we have to make the connection. In agent connect phase you have to connect the port. Driver has sequence item port. That one we have to connect by using dot connect method with the sequencer's sequence item export. So this we done already. So this is another thing. This is optional one. If you need response from the DUT, okay, to the sequencer, okay, so you can use this dot connect to connect the response port of driver with the response export of the sequencer. So driver has sequence item port and sequencer has sequence item export. That we have to make connection here. So additionally, if you want response, you can also do the connection between the response port which is present inside the driver with the response export which is present inside the sequencer. So this sequence item port and response port are the API we are using here in driver. The implementation of this sequence item export and the response port is available inside the sequencer. So get next item is one of the method. Okay. Go to see sequence item port dot get next item. In front face of the driver, we are writing like the sequence item port dot get next item. Okay. So this is used to get or pull the data from the sequencer. So this is a blocking method that waits until a sequence item is available in the sequencer. You see, sequence item is represented by REQ. It is handle of the sequence item. So this is a blocking method that waits until sequence item is available in the sequencer before. Okay. And it returns pointer of REQ. When you put inside the if condition, okay, so it will return the pointer of REQ. And try next item. This is the another method you can use. Sequence item port dot try next item. Okay, you can use. It is a non-blocking variant of get next item. It is a blocking. So until you get the request, it is a blocking, right? So get try next item is a non-blocking variant, and it returns null if no item is available. So it is a non-blocking one. So it will return the request pointer when the request is available. Otherwise, it will return a null. Okay. Inside if condition, you can able to get null. Then item done. Driver by get next item, we can able to get the request, and we are converting the request driver part. We are converting the transaction level to pin level. Then we give a call item done. Okay. So it indicates the sequencer that the driver has proceeded the item and clear the item from the sequencer before. So that means we are getting that and we send to the DUT. Okay. So we have to send item done so that it will remove from the sequencer before. So optionally you can send response within this bracket RSP you can send. That is optional one. If you want, you can send it. Then peak, you know the difference between general difference between get and peak, right? The same way here peak is similar to get next item. okay, and blocks until RUT is available. So the difference is, however, it does not remove the item from the sequencer before. Okay. So get next item, it will remove the request, it will take the request from the sequence before, but it does not remove the sequence item in sequence before. A subsequent item done will be removed. So get is a method available similar to get next item. Instead of that, you can also use get method. It blocks until request is available. However, handshake is completed immediately and there is no need to call item done. When you use this get method, item done is not required. Then put. So put, when we have to use this, I told right, if you want you can use the response, okay, response code. So there you can use this put method to put the response. Okay. It's a non-blocking method used to place the response in the sequencer response before. Okay. When you put the response here, so it will put the response to the sequencer response before, which is available in the sequencer. So unlike item response, put can call anytime independent of handshake. Okay. It's independent of handshaking. So at any time you can call this put response. So this is the overall handshaking mechanism. So this is a sequence and this is a sequencer and it is a driver and here it is the UV. So sequence inside the body method. Okay. So first thing, if you use a tick UVM2, it will do automatically all these steps. Okay. So first thing, it will create item. Okay. By create item, we are creating a sequence item. After this, you have to wait for grant. Okay. So it will send a request to the sequencer for grant. Okay. So once this get next item call happens, the sequencer will grant for the request. So then it will do randomization, will randomize the properties which is available in the sequence item. Okay. And send request. It will send the handle of sequence item. Okay. The sequencer sends, it will send to the driver and this driver, okay, that will convert into pin level and it will transfer to the DUT. Once it is done, we are calling item done in the driver. Okay. So is item done, it will send to the sequencer before that the first process is finished. Okay. Then it will send the item done to the sequence. In sequence there is a method wait for item done. So once it is done, it will go to the next. If you have next iteration, it will go to the next iteration, or it will come out from this task body. Then this one, last one, it is optional. If I need a response from the DUT, okay, if there is any response signal in the protocol or inside the DUT, means if you want, you can also access that by using put response. Okay, so this put response will get this response and it is putting to the sequencer that is used for response. Okay, so from that, by using get response method, we can able to get the response from the sequencer. So this way sequence will get the response for the appropriate transactions. Okay, next is UVM sequence arbitration. So inside the sequencer, okay, we have this type of arbitration mechanisms. Okay. And it's UVM sequence arbitration FIFO. In UVM sequence arbitration weighted, UVM sequence arbitration random, UVM sequence arbitration strict FIFO, UVM sequence arbitration strict random, and UVM sequence arbitration user. So this is the default arbitration mechanism that the sequencer will work. Okay. So if I want to work with this UVM sequence arbitration weighted, so with this method, set arbitration. Okay. So set arbitration is a method available. Okay. In that, I have to mention which type of arbitration I need. Okay. So this one, where I can mention means this one I can mention in the sequence or in test means, so that inside the test. Okay. So how to mention the sequencer? M sequencer is a default handle of sequencer. Okay. So M sequencer, or otherwise you can mention the path of the sequencer dot set arbitration. In the bracket you have to mention the which arbitration you like to use. Okay. So defaultly UVM sequence arbitration before will be available. Okay. Then what UVM sequence arbitration before means? So it is based on first come first out. Okay. So which sequence? So mainly this is used to this arbitration if more than one sequence are trying to access the sequencer driver. Okay. So this sequencer will decide which sequence have to which sequence item will reach the driver. Okay. So that is decided by this arbitration. In first come first out. So first sequence which comes, it will send to the driver first. And second, which one trying to access the driver, that is assigned for accessing the driver. So UVM sequence arbitration weighted. So that is weighted means in sequence, if you see in body method, while randomizing, we are setting some priority. So that is indicate the weightage of each sequence. Okay. So based on the weightage, it will assign or it will grant to access the driver. Okay, which one has the highest weightage, that will access first. Then UVM sequence arbitration random. So when you use this arbitration mechanism, it is independent of weightage. So randomly it will decide which sequence has to access the sequencer. So next one is UVM sequence arbitration strict FIFO. It is similar to sequence arbitration weighted. Okay. So here if you see, it is similar to weighted. Okay, if we have weightage of two sequences are at the same level, okay, so that time it will decide which one give request first. For that it will allot. Okay, when weightage of two sequences stay, so in that it will check for which one comes first and which will, for that we will grant the sequencer, that means driver. Then strict random. It is similar to arbitration random. Okay, here also first it will consider the weightage. Okay. So highest weightage, for example, there are four sequence, two sequence have the weightage 10. Okay. So first it will consider the 10 weightage sequences, and in that there are 10 weightage sequences. In that it will assign randomly, it will assign the sequence to access the driver. Then UVM sequence arbitration user. So this is used to give, that means user can write our own arbitration mechanism in the sequencer, and if I want to use that one, I have to mention this UVM sequence arbitration user. Okay. So inside the sequencer there is a method, okay, function user priority arbitration. Okay. So this function will be defaultly available. You can override this function and write your own arbitration mechanism. Okay, you can get the sequences here, and you can write your own mechanism how which sequence you want to access the driver. That logic you can write, and then while setting in the sequence of test, you have to mention here UVM sequence arbitration user. Okay. So that you can able to use your own arbitration mechanism to access the driver. Then we have a lock and grab of sequencer in UVM. Okay. So this lock and grab is mainly used for locking. Okay, locking the sequencer. Okay. So there are multiple sequences trying to access. Okay. So I want on particular sequence want to grab or lock the sequencer, and it want to complete its whole task. Okay. In that way, in this types of usage, you can use this lock and grab. So a lock request is put the back of the arbitration queue. So arbitration queue is there. So the lock will put in the back of the arbitration queue. Okay. A lock request will be arbitrated same as any other request. So it is as like a normal request. Will put in the back of the arbitration queue. That means a lock is granted after all earlier requests are completed. Only it will grant the previous requests are complete. That is why means that is the reason we are putting this mechanism lock method. The request is putting in the back of the arbitration queue so that yearly task should be complete. Okay, then only you can able to get that sequencer. Okay. While lock is granting, so that time no other lock or grab are blocking the sequence. Okay. So once the lock is granted, any other sequence will not able to block that, or that means not able to get that sequencer. Okay. A lock is a blocking task. When access is granted, it will unblock. So lock is a blocking one until it gets the grant. Once we get the grant, it is a unblocking. So it will complete its whole task, and then it will come out when you give unlock. So if no argument is applied, the current default sequencer is chosen. Okay. Here this method lock within the bracket. We didn't mention anything. It is mean that it will take the default sequencer. So unlock sequencer function is called from within the sequence. It gives a it unlock, that is we are removing the lock for the particular sequence. Okay. So other sequence can able to use the sequencers. So grab. So the difference is between lock and grab is, so here the request is put in the front of the arbitration queue. There the request is put in the back of the arbitration queue. So is there any other request is processing? After complete that, the lock can able to get the sequencer. But here in grab it is put in the front of the arbitration queue. So the priority is given to the sequence which we are using the grab. Okay. So grab request will be arbitrated before any other request. Okay. The grab is granted when no other grab or lock are blocking the sequence. So if a sequencer is free, no other sequence lock or grab is not present, so you can able to get the grab. The only thing that stop the sequence from grabbing a sequencer is pre-existing lock or block condition. If already the sequencer is in lock condition or grab condition, that time we can't able to access the sequencer. Otherwise, if it is free, when you use this grab method, the sequencer will be grabbed by the sequence, and the priority is given to the grab method. Okay, because it is put in the top of front of the arbitration queue. The grab is a blocking task. So until a grant is available. If no argument is supplied, then the current default sequencer is chosen. The same way, lock. If we didn't mention anything in the bracket, so default sequencer will be chosen. So ungrab is same as unlock. Once we complete the task, you can ungrab, so that the sequencer will get released. So other grab or lock, so other sequences can able to use the sequencer. So this is a simple example where we have to mention this lock and unlock. So inside this sequence, UVM is extended from UVM sequence. So this sequence item, I register this to factory, single constructor. Inside the body method, I am doing run.to. So before this, I have, if I mention log, so this sequence will log the sequencer. Okay. Once this process completes, I am on log that. So one more example we will see. Okay, this example I put all the files in a single file, all classes and modules. So here this is I'm typing it's a inversion data type. Okay, inst e it's a data type. It consists of all these strings. Okay, push A, push B, add sub multiply division, pop C. So this is sequence item, section from UVM sequence item. So here in sequence item, I am declaring a property. This is the type of inst. Okay, it consists of all these push A, push B, anything it may carry. I declare as an int E type and I assign random. Then here I register the property and the sequence item to the factory, and this new constructor for this, and I wrote a function string convert to string. Okay, this convert to string, the function out is output by using this dollar f format. Here I am printing int name. Int name I need to display in terms of string how it will be. Okay, there's a string, so I need to display string. So I will the function get. Then with a sequencer. So sequencer, just how to create a sequencer and a function new is enough. Okay. Then defaultly it has its own methods implementations will be available, and also the TLM codes also available. So no need to write anything. If you want to implement any arbitration mechanism by your own, you can override the third user method and you can write it here. And this is a driver. So in driver, by using get next item and getting the okay, and getting the REQ. REQ is nothing but the default handler sequence type. So after getting here, obviously output. Okay. Actual output is this one. Here I am just displaying packet driver percentages REQ convert to string. This function I am calling here. And then after display this, I am calling item done. Then in agent, I have to insert sequencer and driver and insert it here. And then I have to build phase. I have to opt for sequencer and driver. And in this, I have to make connection between this. Here the actual task. Here I put three sequences. Okay. One is sequence 1, that is sequence A. It is external UVM sequence. You should parameterize type of sequence item. Here REQ, I inserted the sequence item inside the task body 4 times. I'm doing this. UVM do with UVM do with is a macro. It will automatically create the sequence item and it will randomize. So while with I am using it, so that means we are applying constraint
Sir,
while
sir,
randomizing.
sir,
Yes,
sir, sorry to say, sir, but actually, screen got stuck, sir.
my screen or yours, yourself.
Uh,
Others
I don't know, sir.
you can
Actually, I
able.
can hear your voice, but the video is like it is still in that code page.
Okay. For others, for everybody it is like that, or
No, sir, for me, the internet is not sharing, sir.
okay,
For me, it
no
got
problem.
stuck in sequence.
Okay, no problem. This video is recorded one, so I will share. That time you can able to see the code along with this explanation.
Yes. Okay, sir.
So here by using the UVM tool with, okay, I am randomizing with this constraint. It is equal to push A. So push A is nothing but one of the variable which is present inside this data type. Okay. So it should take push A. Sequence A always take push A. Okay. Then sequence B. Here also I am inside the task body 4 times. I am using equivalent routing. Here I will write a constraint. It should take push B. So here I use the lock method before the sequence gets started. Okay, inside the body method, I am locked, and after that I am unlocked. And sequence C, the same way I write the constraint that should take push, sorry, pop C. Here I didn't use lock method, so I use lock and unlock it for the sequence B. That means to take push B. Then in the parallel sequence, it is the top level sequence for all the sequence. Here I instantiate all sequence SA, SB and SC, and in body method I create object for these sequences, and I call all the sequences at same time by using fork join. So sequence A dot start M sequencer default unlock sequencer. So I run all the sequences at the same time. And in test, my test is extended from UVM test. In build phase, I create agent, and then here in run phase, we should call this one, right? So sequence dot start sequencer. Okay, this access sequence is present in agent inside sequencer. So here the parallel sequence I should use. Okay, all the sequence are included in parallel sequence. Okay, here I should include that parallel sequence. Automatically the lower hierarchy sequence will be called. When you call this sequence, it will go here and it will call all these sequence. So on top, I just run the test, my test. Okay, when I run it, okay, this is my output. Push A comes first and push B coming 4 times because I use lock. Okay, so lock method will get the sequencer. Actually, uh, if you use lock, it will put the request in the last of the request before. Okay, so first A will get the sequencer, so it will just display the push A, and B after that only B is getting. Once it gets, it will log the sequencer, and it completes the 4 times. So we are getting push B for 4 times. Then C gets and A gets, C gets, A gets. We are getting push A, pop C, push A, pop C in this way. Okay. So instead of this log, if I use grab, okay. So what is the expected one? When I use grab, it will the request is put on the top of the arbitration before. Okay. So top of the sequencer before, right? So first itself It is at the top of the FIFO, because it is at the top of the FIFO. So it will take that one first, and it will process 4 times, and then it will release. After that, other sequence enable to access the sequencer. Here, this is the another way you can mention. Okay, I told right. If you didn't mention anything, it will take the default sequencer, M sequencer. Otherwise, you can also mention like this. So let's see the output. Okay, see here, push B comes 4 times initially. Okay, that means when you use grab, it will put on the top of the request before. Then it will complete its whole process. Then it will release. Then other sequences can utilize the sequencer. Okay. So that's all about today's class.